One of the topics from our mock exam that I wasn't really thrilled with the results on is differential equations, and specifically separating variables. This is usually a pretty important topic on the AP exam. Obviously, it could be a good topic on the shortened AP exam as well. Really, really important to have this down. And the big thing being, it's one of the few types of problems where you get a big chunk of points. You're either going to get 3, 4, 5 points, or you're not going to get any points. Now, not every differential equation problem will ask you to find the particular solution. And typically, if they don't ask you to find it, there's no reason to find it. Usually, if they ask you other analytical questions, it's going to have to do with substituting values in and finding the slope, or finding the second derivative and talking about concavity, or making a tangent line or something like that. So don't assume that just because they give you a differential equations question that you're going to have to separate variables and solve. But if they do ask you for a particular solution, these are the kinds of things you need to be ready for. So I'm going to do pretty basic examples, but I think the concepts will apply to more complicated ones as well. Okay, let's start out with something like this. Do not come in assuming you're going to get a PERT formula. Okay, the only thing you're going to get a PERT formula is dy dx equals k times y, some constant times y. Okay, honestly, they're probably not going to give you that on an FRQ, something that's just kind of a memorized thing. All right, you're probably going to have to go through the steps. So remember, the idea here is you can multiply and divide to get the dx's and the dy's and the x's and the y's all on the same sides. Everything with an x on one side, everything with a y on the other side. Okay, so we start out here. I can multiply both sides by dx. I've got that set up there. Okay, dx's are gone. After that, notice that it is being multiplied by y. So to get rid of y, again, I don't want plus y minus y. It's being multiplied, so I need to divide by y. You might want to think of that as a 1 dy over there. Okay, so what do we have? Oh, by the way, notice I did not move the 8. Okay, because if I move the 8, I'm going to have a 1/8 over on the other side, and it just makes things more complicated if you've got an inside function to deal with on the left-hand side. Okay, it's much easier if that 8 stays in the numerator over here. Okay, technically you can do it, but for most people, algebraic mistakes tend to happen when people move that constant. So leave it where it is. Okay, now, really important, you're taking an integral. Okay, the AP grader's got to see that you take an integral. You can't just magically jump from one equation to another equation. Okay, if they don't see you taking an integral, they're just going to quit grading, and they'll throw out those 5 points and move on to something else. So make sure they can see each step here, and I'm being a little lazy and erasing things. Anyway, antiderivative of 1 over y is the natural log of the absolute value of y. Okay, on the other side here, oops, sorry, y should be gone now. Raise the power by 1, divide by the new power, that's going to be 4x squared plus c. You've got to get the plus c in. Most of the work in these problems is going to involve finding that c value. A lot of times they're going to tell you a point or something like that. So let's say that they told us that this went through the point 2, 1, okay? So at this point, you've probably gotten points for separating variables. You've maybe gotten points for your antiderivatives. It's possible you've even gotten a point for adding c, although usually it's finding c, not just adding c. Okay? Anyway, at this point, you can substitute that point at any time you want. So you can solve for y, but honestly, most of the time, it's going to be easier to substitute that point in now. You do have to watch positive and negative signs if there's an absolute value in there, but that's about the only thing. Okay, so let's stick these points in and see what we've got. X is 2, okay? Y is 1, okay? Remember, the natural log of 1, natural log function crosses the axis at 1, okay? E to the 0 power is equal to 1 is the big fact there. So this is going to work out to be 0 on this side, and that's equal to 2 squared is 4 times 4 is 16, plus c tells me that c is going to have to equal negative 16. Okay, so you can just kind of hold that, or if you want to go ahead and put it in place at that point, you really can. So c is negative 16. There's my equation. All right. Now, typically, if they're giving, say, 4 points, you probably got 3 out of the 4 points already. But anyway, to continue this, to solve for y, remember this is e. This is a log base e. So we've got e to the 4x squared minus 16 power is equal to, and remember it would be a positive or negative y when we take that absolute value off. So this value could be positive or it could be negative, okay? You need to decide. You don't want to leave a plus or minus out in front. If you go back here and look, when I put in an x value of 2, I'm supposed to get back a positive 1 for y. So we don't want plus or minus, we just want the positive one, and we're done, okay? That's all you need to do for this one. All right, let's take a look at a second one here. Let's do dy dx is equal to x over y. Okay, and let's say it goes through the point 3, negative 5. All right, again, multiply both sides by dx. We've got that out of there. Notice that x is being divided by y, so you're going to need to multiply by y. Multiply both sides by y, you're going to end up with y dy is equal to x dx, okay? We can take the integrals of both sides. That's going to be 1/2 y squared. This side is going to be 1/2 x squared. Don't forget your plus c, okay? If you get rid of those 1/2s, you've got to make the change to the c as well. So if I double this and knock out the 1/2, I have to double this and knock out the 1/2. I have to double that c as well and have a plus 2c. A lot of people just kind of have the c floating around there and it's not getting changed like everything else. If you take a reciprocal, the c is part of your reciprocal. If you multiply, it gets multiplied. If you divide, it gets divided, okay? Again, you could probably substitute your point in now and figure out what's going on. When x is equal to 3, y is supposed to be equal to negative 5. Negative 5 squared is 25. That's going to be equal to 9 plus 2c, okay? Subtract 9 from both sides, we get 16 equals 2c. That means c is equal to 8, all right? Once again, you can decide, do you put in the c now or do you just wait till the end of the problem and put it in? But you're going to have the points for having solved for c. 2 times c is 16, so I'm going to go ahead and drop that in right now, okay? Now, most of the time they're going to ask you to solve for y, so I do need to keep going with this. Take the square root. Y is going to be equal to, and remember, when you have an even square root, there's a positive square root and there's a negative square root, and you get something that looks like this, okay? Same thing as before. You have to decide, is it the positive or is it the negative? And you notice here when I put in 3 squared is 9, plus 16 is 25. I take the square root, I want to get back negative 5, okay? So it is the negative square root there, not the positive. That is my particular solution, all right? Let's look at another one. Okay, let's do something like this. How about dy dx is equal to 6x squared y to the 1/2. And let's say that it goes through the point 1, 7, all right? Same kind of thing. Multiply both sides by dx. We've got dy is equal to 6x squared y to the 1/2 dx. Y to the 1/2 is being multiplied, so we divide by y to the 1/2. Okay, so you're going to have 1 over y to the 1/2. Okay, so we've got a 6x squared dx on this side. At this point, we can take the integral. Okay, I cannot stress to you enough. I saw so many people on the mock exam forgetting algebra 1. Okay, that's not a natural log. Okay, that's y to the negative 1/2 power. Okay, negative exponents are really important when you're taking integrals. So make sure, if it's not a negative 1 power, if it's not a 1 over y, you're going to have to use the power rule. Okay, don't assume everything's going to be a natural log. Okay, maybe 40% of the time it's going to be a natural log. The rest of the time it's not. Okay, so take the integral here. Raise the power by 1, divide by the new power. That's going to be y to the 1/2. 1 divided by 1/2 is 2. Okay, raise the power by 1, divide by the new power, you get 2x cubed. Don't forget your plus c. Okay, again, if you want to get rid of those 2's, that's fine. Divide by 2, divide by 2, divide your c by 2 as well, if you're going to do that. Okay, I'm going to go ahead and substitute my point in. This is 1, and oh boy, that's 7. Oh, that's ugly. You know what? I'm not going to sub my point in. I'm going to keep going. I'm going to go ahead and solve for y this time, okay? Sometimes it's easier to solve for c at the start. Sometimes it's easier to solve for it at the end. I'm going to square, that's a square root, and I'm going to square this whole side, okay? Remember, algebra 1, an exponent does not carry through addition, okay? So you're just going to get y is equal to x cubed plus c over 2 squared. Okay, and anyway, we get our answer here. All right, So our y value is supposed to be 7. You know what? I don't think that's... Let's make this a perfect square. Let's make this 9, okay? We'll say that's supposed to be 9, and that's going to be equal to 1 cubed plus c over 2, okay? So anyway, in this case, 9 would be equal to something squared. That means we would need to get 3 would be equal to x cubed plus c over 2. X cubed is 1, okay? So we're going to get 2 is equal to c over 2, and of course that means that c is going to equal 4, okay? Let's check and make sure that really works here. Let's see, okay, we've got 1 cubed is 1, plus 4 is, no, that's not right. Oh, I'm sorry, plus c over 2. C over 2. So if c is equal to 4, that means c over 2 is equal to 2. Sorry. 1 cubed is 1, plus 2 is 3, 3 squared is 9, and we can see that it checks out. Okay, so we had some hiccups there, but works that way sometimes. All right, let's do one final one. All right, final one here. Looks pretty basic. dy dx is equal to x times y squared. Okay, same kind of thing. Multiply both sides by dx. We got the dx off that side. We're going to divide both sides by y squared. That's going to be 1 over y squared. Notice that is not 1 over y. That is y to the negative 2 power. I would write it in that form for the integral. Okay, on this side we've got x dx. We're going to take the integral on both sides. Raise your power by 1 and divide by the new power. That's negative y to the negative 1. I'm going to rewrite that as negative 1 over y because for solving purposes, negative exponents make things a little bit confusing. Okay, you get a 1/2 x squared plus c on the other side. Okay, I would probably multiply both sides by negative 1 to make that positive. So you're going to have a negative 1/2 x squared minus c. Okay, that's 1 over y. I didn't have a point this time, but if you're given a point, you can try to decide if it makes more sense to sub it in now or later. But to solve for y, you have 1 over y. You want y over 1. So you need to take the reciprocals of both sides, okay? And that's the entire side, okay? You're taking that whole thing's reciprocal, and that's going to be 1 over 1/2 x squared minus c. Okay, and again, if you want to double the top and double the bottom, you could get rid of that. You could write that as 2 over x squared minus 2c, something like that. But that's the basic idea, okay? So I'm not going to substitute a point into that one, but hopefully you get the general idea. Don't make assumptions. Be very careful. Most of these points are very gettable. The derivatives don't tend to be bad, or the integrals don't tend to be that bad. The substituting in the point doesn't tend to be that bad. Keep in mind, you may have c being something like e squared or radical 3 or something like that. The numbers are not always wonderfully pretty, but it doesn't matter. They don't ask you to simplify. You don't have to simplify as long as you go through the things that they ask you to do. So hope that gives people a little bit more of a review on a topic that's super important on the AP exam.